Hello and welcome to this, which is the third episode in our lecture series on Python. In this episode, we're going to introduce two forms of flow control, while loops and if-else conditionals. Don't forget that you can pause the video at any point and try out the exercises in the code window below this. Arithmetic and assignment statements are all very well, but the real power of programs comes from repetition, which is the ability to do something many times, and selection, which is the ability to do one thing rather than another. The simplest form of repetition in programming is the while loop, which does something as long as some condition is true. For example, here's a small program that prints out the numbers 3, 2 and 1 using a while loop. The loop opens with the keyword while, followed by the loop's controlling test. Now, since this test is true, i.e. since number of moons is currently greater than 3, Python executes the statements in the loop body, which is the indented set of statements under the loop control. And this prints out 3 and subtracts 1 from num_moons. Python then goes back to the while statements and rechecks the condition. It's still true. So this time the program prints 2 and again subtracts 1 from num_moons. Another check, another print statements. The program prints 1, then decreases num_moons again. And since the loop's controlling condition is now false, the program's done. So a while loop can execute any number of times, including 0 times. And in this piece of code, for example, num_moons is initially set to -3. So that when we meet the loop condition, it's false the first time it's tested. And the loop body doesn't execute at all. So the output is therefore the two lines before and after, with nothing in between. And it's important to keep this 0 pass condition in mind when we design and test code. And if we're not careful, a while loop may also execute forever. So let's take a look at this code again. This copy of the program doesn't subtract 1 from num_moons inside the loop body. So it prints before, then 3, then 3 again, and then another 3, and so on. And since the loop's control condition was true when the loop started, and we do nothing inside the loop to change it, the loop will run and run until the user gets bored enough to halt the program. Now, this is usually not the desired behaviour, but there are some cases we'll see later where an apparently infinite loop might be useful. So you might have noticed some indented code. So why does Python use indentation to show which statements are in the loop when other languages use perhaps begin or end, or sometimes curly braces? Well, studies have shown that's what people actually pay attention to. Every textbook on C or Java has examples where indentation and bracing don't match, which makes it harder to see the errors in programs, and Python simply avoids this problem. It doesn't matter how much indentation you use, but the whole block must be consistent. So if the first statement's indented by 4 spaces, the rest of the block has got to be indented by the same amount. Now, Python has a style guide, it's called PEP8, and this recommends 4-space indentation. And please use spaces rather than tabs, because different editors display tab characters with different widths. Now, while loops allow programs to repeat things. If, elif, and else allow the programs to make choices. So here's a little example. Now, since moons is not less than 0, the program doesn't execute the first block of code, which would print less, and similarly moons isn't 0, so the second block isn't executed either. And finally, since no other choice was taken, the statements under the else are executed. And this program just prints greater. A set of choices like this always starts with if and a condition. It can have 0 or more elif clauses, and each of these has its own test. And optionally an else with no test to execute if nothing else is done. Tests are always tried in order, so as soon as one test is true, its block of statements is executed and no other branch is tested. Of course, blocks of code might contain other blocks. So, for example, in this program, an if is nested inside a while. The while counts from 0 to 10, and the if prints out the odd numbers. And this combination prints out all the odd numbers between 0 and 10. But here's a better way to do the same thing. This time, let's start num at 1 and add 2 to it each time as we go through the loop. The loop runs half as many times, but the output's the same. Writing a simple program that works, then tweaking it to make it more efficient is a common pattern in programming, and others to write programs top-down, solving one problem at a time. So let's see how this works. Let's write a program to print out all the prime numbers that are less than 1,000. The skeleton's simple. Start with 2 because 1 isn't a prime, and loop up until 1,000. If the number's prime, print it out. Now, by definition, a number's a prime if it can't be evenly divided by anything except itself and 1. And the simplest way to check is to try dividing it by each number that's less than it, so we write another loop. Saying that it can be divided evenly is the same as saying there's no remainder. This tells us how to fill in the last bit of our program. So putting the whole thing together gives us this, which is just the bits of code we wrote but put in order. But as ever, there's probably a more efficient way to do it. Now this code is almost the same as what we just saw, but it takes advantage of the fact that a number can't be evenly divided by anything greater than its own square root. Now this is a pretty neat idea and it can save a lot of work, but unfortunately this program contains a bug. And as a lot of programmers will tell you, any code that hasn't been tested is almost certainly wrong. So let's have a go at changing the bound on the outer loop so that we only print out the primes up to 10. So here's its output. Hang on a minute. 4 and 9 aren't primes. So where's the bug? Now, one clue is that failures occur for perfect squares, and 4 and 9 are both perfect squares. So let's have a look at the one thing we changed, the condition of the inner loop. 2 squared is 4. But in this case, the loop condition is less than, so we never actually check to see whether 2 can be divided by 4, or whether 9 can be divided by 3, or whether 9 can be divided by 3. The condition should be less than or equal. So the condition should be less than or equal. And if we make this change, the program produces the correct output once again. So before we move on, have a go. Take a look at the questions below. A chance at the questions below.